Hey everyone, welcome back to another geometry class. Today, we are exploring one of the most elegant and useful circle theorem, the two tangents from an external point theorem. We'll understand it, prove it step by step, and solve example together in the simplest way possible. So, let's jump right in. The theorem says the length of two tangents drawn from an external point to a circle are equal. Let us use this diagram to explain the theorem. PA is our tangent, PB also is our tangent. The theorem says the length of PA is equal to the length of PB. Let us prove the theorem. Let us consider this diagram. This is our circle with center O. PA and PB are our two tangents. Now let us join OP by drawing straight line. Now remember, the radius is perpendicular to the tangent at the point of contact. So I can say the angle between this line and this line is 90 degrees. An angle between this line and this line is 90 degrees. That means both triangle OBP and OAP are right-angled triangles. Also, our OB and OA are equal because they are radii of the same circle. OA equal to OB, radii of the same circle. Also, our OP is equal to OP. OP equal to OP. They are common side to both triangles. Triangle OAP is congruent to OBP by using right angle hypotenuse side rule. Triangle OAP is congruent to triangle OBP by using right angle hypotenuse side congruency rule. Triangle OAP is congruent to triangle OBP by using right angle hypotenuse side congruency rule. PA equal to PB because corresponding sides of congruent triangles are equal. That is the proof for the theorem. Let us consider this example. From an external point P, two tangents PA and PB are drawn to a circle with center O. If OP equal to 13 centimeter and radius OA equal to 5 centimeter, find the length of each tangent. Let us represent this using diagram. This is our circle with center O. Our external point P is this, and our radius OA is this, and our tangent is PA and PB. So let us join OP together, and OP is giving us 13 centimeter and OA is giving us 5 centimeter. 5 centimeter. Let us join OP. 13 centimeter. And I want you to remember that radius and tangents, they meet at 90 degrees. So we can use Pythagoras theorem for our triangle OAP. We can say OA square plus PA square equal to OP square. OA square plus PA square equal to OP square. And it is given to us that OA is 5 centimeter, OP is 13 centimeter. Let us substitute them into this equation. 5 square plus PA square equal to 13 square. 5 square is 25. 25 plus PA square equal to 13 square is 169. 169. Let us bring 5 to the right hand side and change the positive sign to negative. PA square equal to 169 minus 25. PA square equal to 144. Let us square root both sides. Square root PA square equal to square root 144. This cancel this. PA equal to 12 centimeter. Square root of 144 is 12 centimeter. But by a two tangent from a point theorem, we know that PA equal to PB. So PA equal to PB, which is equal to 12 centimeter. Before we wrap up, let's quickly review. Tangent touches the circle at only one point. PA and PB are our tangents. The radius is always perpendicular to the tangent. The radius of our circle is always perpendicular to the tangent. Tangents from an external point are equal in length. We have proved that length PA is equal to length PB. Also, I want you to know that the line joining the external points and the circle center bisect the angle between them. That means this angle is equal to this angle, and also this angle is equal to this angle too. If you enjoy learning this, give this video a thumbs up, drop a comment with your favorite circle theorem, and don't forget to subscribe for more geometry class. Check out the next theorem in the playlist below and keep learning the easy way with Teacher B.